So we'll start where we just left off. We're now going to support JT Open files inside Edgecam 2018 R1. This is a brand new solid model file which all our users, indeed users with the Solid Machinist for Parasolid license, have been using for many years to be able to support this type of file. If you've not heard of it, you will do in the future. This is almost like the new X_T Parasolid file. So certainly as a CAM system, we need to support our customers. Needs to support our customers in respect to this sort of in respect to this type of file. Okay, moving forward, so that's our JT Open file, the first part on our list. I know there's some people who are just joining webinar, so good morning to you all. Apologies, we had a couple of audio issues, but I think we're all back underway now. And we've just gone through our first slide, which is just talking about support for a JT Open file, which is a new Parasolid style file, which the CAM industry is now supporting. So, talking about CAD files, we also now support 2018 AutoCAD files. So there's still people using DXF and DWG, so it's right and proper that these files be supported. You know, we're not just a solid system. You know, there are still people out there using lines and arcs and this sort of data. So be it that we should support them. And just more of a technical note, because we did support this back in 2017 R2, but Creo 4, we're now supporting all data coming in through the spatial interop. So that's the third-party software which Creo themselves use. So that's now supported. We did support this at 2017 R2 as well. But now we've come along with the spatial interop, and that's to support the tolerances, threads, and so on and so forth. More of an aesthetic type enhancement here, the Workplane marker. So now we display the marker in different types. And what we've got to remember that the Workplane marker, we used to call it the CPL, this now performs different functions. It can be the component datum, the mating location, or indeed the machine location. So all these are quite important types of functionality that we use day to day in our software. Of course, you may be asking yourselves, well, if I don't set these datums, how would I deploy them later on? Well, there is a filter item inside preferences, so just use that filter item, and you'll see how that command works. This is probably one of the biggest ones, reducing unnecessary regeneration in Edgecam. We get very frustrated. We waste many minutes during the day in respect to the time given up when we edit a tool, and we'll see actually many different enhancements with this in the future. But with this particular release, we're specifically looking at when we edit a tool and some of the different items inside a tool. So if you change some of the coolant and maybe some of the code generator settings, it's not necessary really to go ahead and do a regeneration. That's the current situation that we find at the moment. Indeed, what could be more time constraining as well is when you change something inside a loading area. This again has nothing to affect cycle time. So you'll find that we cut away all that extra unnecessary regeneration. We will have obviously a small piece of local regeneration if we change the maximum RPM, if we change the number of teeth on a cutter. So these will come through, but only local regeneration, in other words, the cycles that affect that particular tool. The most severest example is, and I'll do this in my demo, is when we actually edit the comments in a toolpath, in a cycle. We find that there's a lots of regeneration time taking place there, so that's been cut out in 2018 R1. We continue to evolve images on tooltips, so again, even for the most highbrow user, brand new cycles, such as the two that we see here before us, the 3 to 5 axis and in turning the B-axis contouring. These are relatively new, so it's right and proper that we put pictures on dialogues for these to explain what those commands mean. The picture speaks 1,000 words. When we're in the machine simulator, we'll now find that we've got the ability to affect the spinning of the tool. It's true to say that yes, we had spin-driven milling holders inside, options inside the simulator, but it's no longer, that never or would it would obey what it saw inside the inside the tool change. Now we can overwrite it, or as I say, it will now be genuinely obeying what it sees inside the tool change. So in other words, if you had a probe or any type of tool that shouldn't move, therefore it shouldn't move inside the simulator. So that's now true to the spindle condition inside Edgecam. So this is what you had before, and now you see it spinning. And I'll make a more obvious example when we go to demo. Furthermore, what we see here is when we're editing a manual feature, we're able to do that. This wasn't necessary before 2018 R1. Unfortunately, we'd have to rebuild the faces again, or we'd have to rebuild the edges again. Obviously, that became very, very time consuming. Now we can do that, and obviously the toolpath is associative to the new feature. And for those of us with the advanced 5-axis, we can now say use the current stock command. So again, that used to be a manual input. You had to physically pick the command. That's no longer necessary, as I'll show you now inside a demonstration. So we'll just open up Edgecam, and here we have, as you can see, 2017 R2, a pretty normal size part. And this is all to do with the regeneration. So if I go to the roughing cycle and I request Edgecam to make a change inside this particular roughing cycle. Now, in terms of the cycle, obviously, yeah, there's lots of parameters in here that would have to regenerate. But if I just make an innocent change inside the comment, which clearly wouldn't need, that doesn't affect cycle time, it doesn't affect speed, it doesn't really affect anything, it's just a message to the programmer. As you watch carefully on the left-hand side, and you'll all be used to seeing this, you'll see the cursor spinning, and we'll see the usual generating CL information on the bottom left-hand corner. That's obviously regeneration taking place, and that's obviously time ticking away. If I do the same in current version, so let's have a look at 2018.1, exactly the same file, and again we'll make exactly the same change. All I've done with this file is just brought it through and resaved it in 2018 R1. So everything is it's a clear and it's a fair race between the two of them. So again we'll just put another name in here of 2 or something, and if we answer OK, we'll see that we get 0 regeneration. That's absolutely stop dead for us. There's no regeneration taking place. If we come back to 2017 R2 on screen, look at the bottom left-hand corner, you'll still see it's making its way. It's still doing the number crunching, so that's wasted time. So the beauty of this particular enhancement is obviously time saving. If I were to go and make a change here in the 50mm cutter, and again there's things in here that would need to be locally regenerated, such as I said before, spindle speed and feed per tooth, some items here. But I'm not going to do that. I'm just going to say, well, maybe let's just turn on our code generator high speed mode. And if I answer OK, again, watch the bottom left hand corner, there is 0 regeneration. So that's going to save an awful lot of time. Indeed, if I just slip back to 2017 R2, I think we've just about finished our regeneration. So you can see there's quite a bit of time being saved here. Okay, so let's move forward. Let's just clear this particular part. I wanted now to speak about the different types of files that we use inside Edgecam. And there's a new file that we've exposed to 2018 R2, which is called a JT Open file. If you loosely read, if you Google JT Open file Siemens, you'll discover that this is a brand new CAD file which has now come to the market. And there we see the file here, the JT Open file. And just to talk and just to demonstrate this type of file, and also to demonstrate some of the other items that I spoke about inside the PowerPoint, I'm just going to open up this file and we're just going to do some ordinary machining to it. And so I'll just take us through, just give us the opportunity to go through those enhancements which I spoke about earlier on. So if we just simply maybe just take this file about, just like a normal file, and we'll fit some stock on there in the time-honoured way. And we'll just wait for we'll put no millimeters around this. It's fine. So look at the work planes. So look at the blue work plane. So that's obviously a new symbol, and that's what we call the component work plane. So we just flagging up, we've got a different type of workplane here. If we create a workplane, or in the old words, a CPL, and I say that this is my G55 CPL datum, and I'll say face normal, origin, and I'm singling out this for special attention. It's a machining datum. So in the time-honored way, I'll just simply get asked, where is my planar face? Where is position for datum marker? And you'll see the appearance of the datum marker is very, very different to the first datum marker. So it's just basically an aesthetic ability to draw the user's eye and to say, take notice of me, I'm different to the other one. Let's do another one. Let's create a new datum called location. This is face normal, and we'll have this one now is going to be a mating location, so different to the machine datum. And I'll create the datum in the usual way. So I'll say let's place the datum here, and the origin is at X, Y, and Z. And I'll just say it's in X in this position, it's in Y in that position, and Z in that position. And what that will do is it will create another datum on the bottom. Let's just do a render out. Now you'll see a different appearance of datum. So we've got a component datum in blue. We've got machine datum, which you can see is the traditional data marker. And we've got a location datum. And what we're just simply doing is just trying to flag up the different types of datum that users do use generally day to day inside Edgecam. And although on a maybe a simple part like this, it wouldn't be maybe too important, but you imagine user with multiple parts being multiply loaded into say a tombstone or a multi fixture. These sort of people do tend to use a huge amount of datums which are for clocking, datums which are to be feed the component in. And here we see an example of it. It's just said, well, the only datum legally to be used here is the G55 datum. Over on this side here, it's using the location datum. So on a small part like this, maybe not very important, but on a huge tombstone part, where you can have 30, 40, 50 different types of parts, it can become very, very cumbersome to wade through all these different datums. So now we have our datums clearly signified. So now we're in manufacturing, and I spoke about having a new type of feature, or rather an enhancement to the profile feature. So when we do a manual feature, we just simply select these edges, and we'll machine with those edges later on. But what will become relevant is that we'll be able to edit those edges. So we'll just pick a tool to do some machining. So I'll just do an end mill. And so this tool is going to have a particular type of back end on it, and this will just allow me to show the new type of parameter that we see inside the machine simulator. So you'll notice with this tool we've got a milled flat, and obviously so when this particular tool is used inside machining, it would obviously be spinning, so we need to see that milled flat being spun, and that wasn't always possible in previous versions. It would remain static. So Edgecam's now deciding between, if that's a genuinely spun tool, then do so, spin it round for me, that's right and proper. But obviously if it was a probe or a brush or something of that nature, it doesn't need to be spun. So I'm just going to set up my cycle, just check my parameters are good here. I think we're all doing well. Lead good, links down to, yeah, and so we'll just simply choose, in this particular case, the feature to machine is a 2D profile, and we just get some machining. Now if I hop along into the machine simulator, what I just want to talk about very quickly inside that machine simulator is the fact that the back end is going to be spun around inside the machine simulator. So if we just play this through, let's just hopefully that webinar will catch up. So there we go, that is now being spun round. So it's been true and genuine to what it's been told inside the spindle option inside Edgecam. You can overwrite it, and that's the explanation here, that we're spinning or not spinning the tool itself. So that's me now overriding it. I wouldn't want to do that, obviously. A milling cutter would always want to be spun. If we come back into Edgecam, we'll just do a little edit to that feature. And this wasn't at all possible in previous versions of Edgecam. If I just now have the new coord input button, and I select another feature, another edge I should say, notice now how it's been editable. Before I would have had to unselect everything. Everything in the feature would have had to be unpicked, and then have to re-pick everything. Now this is only a baby part. 2 or 3 picks aren't going to hurt me, but of course if there's like 20 or 30 picks, that can be quite time consuming. So this is something that got developed 3 or 4 versions ago for turning, and it's now been brought forward into the manual mill feature. So I'll just do that one more time. We'll just pick that other edge. You'll see how it will join the next edge for me there. Okay, moving on. The last item to talk about was the advanced 5-axis cycle. So this again is the most. It's quite true to say that most users will use this advanced 5-axis cycle if you've got that type of machine tool, or indeed, if you've got that type of license as well. The license itself is probably the main license that we sell inside the 5-axis world. There's a standard and there's an advanced, and this is the advanced that we see here. And what we see here on screen, let's just webinar to catch up. Yeah, obviously lots of fresh air cutting, so that's not very good. And what we would have generally done in the past, we would have gone into the cycle, and inside the cycle there is an option to just do a pick. Sorry, I should say a pick from the interface. Now, what we'll find within the cycle that's no longer necessary. Within the cycle itself, we'll notice that there's an option which allows us to just do that. Does an automatic pick within the cycle. Okay, we've got a couple of questions coming in. Let's have a look at those questions. I'll just come back to webinar, and we'll just turn back on. So, yeah, regarding the JT Open file, that is going to be with all Edgecam users, as I maybe have said. You might have come in on the webinar a little bit later, but for sure you'll find that that's now all Edgecam users should be using, and indeed can use that functionality. Just look for any more questions. So just, because if I miss any questions today, then fear not. We'll obviously pick these up later on. No, okay. A bit of a shy bunch out there. Okay, so we're all good. All right, so let's just resume, and we'll go back to PowerPoint. This was the item we were just speaking about, the use current stock. So we're able to, rather than do a pick through this command, the advanced 5-action now says use the current stock, and that will save us from, well, to just do another manual pick. So the whole idea is to try and get away from manual intervention. The more manual intervention that we have inside Edgecam, it obviously means that we're going to be wasting more time. A little bit like the regeneration that we saw previously. So here we go now. So you see now it's now being trimmed back to the face. Okay, so back to our PowerPoint and back to turning. So let's just get our screens set up for our next bit of this webinar. There we go, so turning. So anybody with turning licenses, and this is the advanced turning license that we've now got. We've enhanced the B-axis contouring cycle. So this was brand new at the previous version. What we'll now notice, this has been done some cutting trials with a number of business partners and indeed customers, and it's been requested that we need to have more spline output data. So basically there's something called maximum angular increment, and by placing a value in here, Edgecam will output more X and Z values into the code, and by doing that we'll obviously find out that this gives us a more accurate, much more accurate toolpath. This is what we would have had before, and this is what we'll have now. You see those little stripes, they're called toolpath normals. So the more normals that you get, the better the toolpath, the more code you're receiving into the program. Inside the rough turning cycle, we'll now find that we've got collision checking. So this again is a big time saver. We don't have to manually see where the toolpath is going. Edgecam's going to automatically remove and make a toolpath safer. And in previous versions of Edgecam, rough turning cycle, we had certainly 2017 R2 and before, profile extension was grayed out, and that was an annoyance because we want to make the toolpath go beyond the stock. So now we'll find at 2018 R1 that restriction has now been removed. So this would have been before, where we're just stopping bang on the edge of the stock, and this is now. We'll be able to push it beyond the stock. And obviously if the stock changes, then the size, the value will change as well. Okay, let's have a look at that in glorious Technicolor. So we'll just push along to our turning. Just open this one. Say no there. So this item, this is to do with collision checking. So we get an automatic fixture and collision checking inside rough turning. This is the first of its kind inside turning. We see this inside milling quite a lot. Update fixtures and update stock and these sorts of things. But we're seeing now these new enhancements coming through inside turning. And this particular feature isn't just good for a manual user. We'd find that this was also good for a strategy manager user, somebody who uses automation. So you can see here we've got quite a big crash going on as the tool enters into the cut. There we go, not very good. And of course we'd know what to do with that. We'd be able to go to the start and end points on the left hand side and pull back the star and the arrow. Well, that's no longer necessary. And of course it's okay if you can see that. If you're working in Strategy Manager, you're not able to detect that. So now if you look inside the advanced options, we'll now notice that we've got collision check on the main spindle. And of course in this particular case we'll just refresh the toolpath, and automatically, without having to move the star and the arrow, you can see now it's corrected that toolpath for us. Now that's probably okay when you've got just a one-off part like that. But of course this will clearly benefit users who've got multiple chucks, sub-spindle and main spindle, and obviously multiple turrets as well, lower turret, upper turret. And obviously on a sub-spindle lathe you can have 4 upper turrets, lower turrets. So there's quite a bit going on, and obviously a lot of users will use the turret as the chuck or a sub-spindle as a work steady or kind of like a bar pull idea. So again, it's right and proper that we check all these parameters, and to save the user having to do that, we get Edgecam to do it. So again, you can see on the screen just to play back the toolpath. There's trouble here. We're obviously wiping out a tool to the left and now the tool to the right. And of course this can be corrected. We know how to correct that because obviously we have the stars and arrows. But now we don't need to do the stars and arrows. Now the stars and arrows are almost being made redundant, because if we look inside the control parameter in advanced option, we can say check on spindle. So I'm checking to the left hand side, and then we'll check over to the right hand side. So this is now sub-spindle being checked, and this is the other spindle. So advanced option again, and check on the main spindle. And these will be probably left on by default. As we know, everything in Edgecam is last in, stays in, so it is going to be defaulted. So there we see the nice, perfectly safe toolpath. For those of us with the B-axis contouring cycle, and this was a new beast which came out at 2017 R2. People with ATC and cigarettes, that style type of machine tool, able to contour a very complex type of shape. So rather than having to buy very expensive types of inserts to try and fit into all the nooks and crannies of a component, all they simply do is just they change the angle of the head. So what we see here is, and what these little stripes represent is a toolpath. So before, you just look at those toolpaths there, we see that on this quite complex spline curve, I could do with maybe some more X and Z output. So if I just hide away that particular toolpath, and if I were to amend the toolpath, just make that visible, now you'll see you get more stripes being created, which we call these toolpath normals, and this is due to this parameter here, maximum angular increment. Placing a value in there just makes Edgecam calculate more, makes Edgecam think about it a little bit more, and so basically speaking, if you were to derive the code from this particular part, you'd see that there would be more X and Z coordinates in that code inherently. Therefore, it would make the program a lot more accurate. And of course, we're not really too bothered about the code being large because it's a very expensive component. Besides code, there's no tax on code at all. You know, we can make as much code as we wish to. So the final enhancement here with respect to turning, and again we'll just play back this toolpath, just a normal toolpath, boring, going through on this billet. You'll see how it stops precisely on the back of the billet, and that's because in previous versions Edgecam didn't allow you to push it beyond the stock. So this user's set up the rough turning cycle, and that cycle has been told to be true to the current stock, and that's exactly what it's doing. It's perfectly correct in its output, but previously we would have seen profile extension being grayed out. Now we see that profile extension is open, and just by placing in some values inside there, you can see now I can push that beyond the back of the stock, which is right. I want to genuinely guarantee that this will break through and clean up the back face. So that's just the final enhancement we have inside turning. So we'll just move along to milling. I'll just open up the next file, and we'll break back to the PowerPoint. And so we're good to go for milling. So with milling, first enhancement is we now support deep hole drilling, which we would have called gun drilling. We have, in kind of roundabout terms, have been supporting this in the past. We've been supporting it simply by you've been creating a lot of longhand cam instructions. So this is the sort of thing that you'd see, or some people have written little PCIs or macros to get around it, and obviously that's very, very time consuming. So we have 26 cam instructions there on the right hand side. This can now be whittled down to one cam instruction. It's all contained within the deep hole drilling cycle. And how does it work? Well, very, very simple, which is what we like. We have a new radio button called Deep Hole, and that opens up a new tab that allows us to specify the feeds and speeds for the different stages of deep hole drilling. Of course, it's simulated as well. At the moment, this is supporting longhand code. We don't expect it to support CAN cycles. There's not many CAN cycles out there that we believe can actually do this properly. But of course, if you have a CAN cycle and you want to try this option, then by all means drop us a line, and we'll write out an enhancement request for you. Another time-saving item is this pass feature boundary to the cycle. So we see lots of times when we're machining a feature, we want to use the boundary on the feature, and this is particularly relevant on open pockets, open mills, and flat faces. This will also help Strategy Manager authors. They don't have to physically draw a boundary. This is the sort of thing that we see. This is the part that I'm going to demonstrate at the moment. We've got a good toolpath, but it's a little bit wasteful. We see the cuts around the back, and now we'll see this. We'll see that we've got the cycle has now been nicely contained, because that's because it's using the containment boundary on the feature. Another time-saving command is detect undercut stock, which you'll find inside the roughing cycle. So we've been quite genuinely true to the stock, but there are a number of occasions, not many, where we don't fully detect the stock. And this item that you see on the screen, where we've got a tube, that's a very good example of it. We'd get unnecessary toolpath in the center of that tube. So we're going to improve the toolpath, and obviously this will allow us to save more time, because it's not cutting fresh air. And the majority of customers will enjoy this because it's on the standard production license. So this is after. This is before. See the toolpath wasted away there where there's tube, where there's no material. And then we'll find that once we apply the enhancement, it will take away those nasty extra toolpaths. In the roughing cycle, a real popular is waveform machining. We've now improved the approach type, so we're now noticing that we've got minimum and maximum values. So this allows us to have a better scope of approach. Lots of tool manufacturers do nag us to state the upper and the lower radiuses when we do helix, and this is now completely true inside 2018 R1. And finally, or nearly finally, inside the profiling cycle, we now have spring cuts. So we all know what a spring cut is, just to take away the elasticity on a piece of material. We've been maybe doing this in the past by just simply copying the profiling cycle and let it do a neutral cut. That would obviously end up with lots of cuts. So what we want is less CAM instructions, so the actual spring cut is done inside the cycle. This is simply what we'd see. You'll find it inside the multiple passes, and of course we can determine where the spring cut is applied. Is it on all the cut increments, or just the final one? And obviously we have tested the code here. This is fully compliant to G41, G42, or whatever type of compensation you use on your controllers. Another newish item is, again, this is applicable to the profiling cycle, and still to do, well, it's purely to do with cycle time. We've been coding for profiling cycle correctly for donkey's years, and this is specifically to do with the GO2 and the GO3, the circular interpolation moves. We have been mathematically correctly bringing down or speeding up the GO2, GO3 due to the trajectory of the tool, and this has been done by the code wizard, but the cycle time hasn't been affected. So we get the right code, and we've always had the right code, but now we'll find that the cycle time is also corrected, and that's done within inside Edgecam itself. We don't need it to be done inside the code wizard, inside the post processor. So it's just this one checkbox that you need to remember: adjust feed rates on arcs. Very, very simple little command. And of course, as I said before, this will affect our cycle time. Okay, so let's go back to our toolpath, back to our presentation, and we're going to talk about the cycle time in milling. So when we code out for this part, and obviously we've got a lot of radiuses on here, lots of arcs, this goes through our code wizard. And inside code wizard, there has always been circular interpolation, adjust the feed rate, and then we'd say adjust it by so much. Okay, and the net result of that is, if we look at the output, you'll see that when we're doing a GO1, we're at 800. Where we're doing external or internal GO2s, GO3s, notice how wherever we do any type of circular interpolation, we're getting an adjustment. And that's exactly what we want. But the issue's been is that our cycle time hasn't been perfect, and this is where the small fall down has been. This should really reflect what we see generally on the machine tool. This has always been an approximation. So at the moment we have 13 minutes, and of course the theory should be is that if I went into the code generator, changed my circular interpolation, and lifted these up quite high, did my apply, my OK, my generate or recompile the post processor, then came back to Edgecam and reran this code, I'd get my feed rate values changing, but I wouldn't get my, there we go, my cycle time changing. So this should really change. So now what we'll find if we look inside a profiling cycle, and again it's completely an option for a user to use or not use. You don't have to rush into your code generators and start changing stuff. You just change it here. So the feed rate adjustment is down inside Edgecam itself, and it's within inside Edgecam where the cycle time's been calculated. So we've gone from 13 minutes down to 12 minutes and 24. And this again is quite a small part. You know, imagine a part with many profiling cycles, lots of radiuses where the trajectory of the tools are being altered all the time. This would result in quite an inaccurate cycle time. So from 2018 R1 and onwards, that cycle time adjustment is going to be done inside Edgecam, and it's not going to be left to the code wizard to do it. So moving on, the other item I would like to speak about was to do with the boundary. So boundary control, as we know, clips back or chaperones back the toolpath. And in this particular example, what we'd like to see is the toolpath being a little bit more accurate, a little bit more efficient. And in fact, can't really blame the toolpath because it's perfect. We are saying to the toolpath, use the stock. So here is the stock. So it's done this correctly. And it's obviously even negotiated around the back of the chuck. And we're at 1 minute 29. But we might say, well, actually, there's a little bit of wasted time around the back here. We may want to cut away this area here where my cursor is. And we're at 1 minute 29 at the moment. So of course, the way we'd do that, we'd have to do an extra pick a boundary. Indeed, we'd have to maybe even create the boundary. So what we'll now find is that inside the property area, so maybe that's an area that you're not too used to looking at. So here are the features to the left-hand side. Now we've got a property area. This property area has always been here, and Strategy Manager authors will know about this, but a manual user may not. But this may now interest you. We can now say, pass the boundary to the cycle, yes. I'll just save that. And we just do the same to the other one. We've got two flat face features here. Pass the boundary to the stock, yes. Tick. And so what we'll discover is that these two cycles, I just pick them out, we'll do a regen, is that these two cycles now will readjust themselves, and you'll see what just happened. It pulled it back onto the boundary. That's because it's been true to the boundary from the feature, and we've gone from whatever time we had before. So we've got 1 minute 29. We've now gone down lower because obviously we're not cutting as much fresh air. So we'll just come to rest here, and we've got down to 123. So it's a nice little bit of a time save, and that's just simply done by passing the boundary onto the cycle, and we're doing it through the feature. We're not doing it through a manual intervention. Of course, the idea is that the more manual intervention that we do, it obviously costs us time, and it costs us money to produce more parts. More parts, obviously more time. So less time that you're actually taking to create CAM instructions. The better the time saving, the better the saving inside your CAM instructions. And the other one is, and this again is a very interesting one. You know, where is the room for improvement with the roughing cycle with respect to the stock? And so we see here that this is a tube of stock, but we've got toolpath where really there shouldn't be toolpath. So this is a 6 minutes and 34 seconds of time. And we'll just throw this into the machine simulator. What we've always seen inside Edgecam is that inside a roughing cycle, provided that we've said update the stock has been represented correctly. And we'll see here that we've got toolpath where really there shouldn't be toolpath. So to try and get more benefits, we can now say detect the undercut stock. So we're at 6 minutes and 25. Let's just take that final cam instruction number 7. And what we'll say to number 7 is we'll switch on this new facility that we see in 2018 R1, detect the undercut stock. So that will go away in and do its number crunching. And what we'll notice is that the tool stripes that are contained or were contained in the center are now eradicated. It's more genuinely truer to the tool, to the area of stock that was originally there. And there we go. Now it's down to 4 minutes 12. So we did have on the top there 6 minutes 34 on the old tool path, and now we've gone down to 4 minutes and 12. So that's a very, very big cycle time saving. Give you another example here. We'll just change tack. That's on a turning part, a mill turn part in the CNY world. We'll just open up our next file. Oh yeah, question coming in there. Just noticed that yeah, if you check, it was about the this particular item. Yeah, when you check an item, when you turn an item on in Edgecam, it stays on. It's known as the modality link, and so that's the kind of a behaviour that you see quite a lot in Edgecam. Why wouldn't you want it on turning, which was the question from the turning demonstration? Just simply time. If you ask Edgecam to check for chucks and check for collision avoidance, it just takes a little bit longer to do the thinking, to do the calculation. So that's why you may not want it switched on all the time. Okay, back to this part. So we've got 2 minutes and 26. We're on an indexing machine tool, quite a complicated 3+2. We've indexed, and we're noticing that we've got some spurious toolpath over here. It's just noticing there's a small bit of extra toolpath or stock towards the back, probably finding some extra stock down on this baseline over here. Now the way we would have got around that in the past was to again draw a boundary, but that's obviously wasteful. So if we now do a detect current stock, undercut stock, you'll notice now it's pulled that back, and now we've got a much more cleaner toolpath, and obviously that's going to save wasted cuts again. Let's have a look at waveform. So again, this is something that should be every Edgecam user should be using. I can't really see a reason why you wouldn't want to use waveform due to the efficiency and the cycle time savings that you get with waveform. Obviously, not only just cycle time, because you can increase your fees and speeds quite dramatically and your depth of cut, but also you can enjoy quite large benefits in tool wear. So here we have a very, very typical toolpath, just on a little kind of a microwave parts, lots of ribs and little islands, upstands, and we're finding that this toolpath won't go any deeper than the first set to the first level. It should really be going all the way down to the base. So that's because the radius, the helix that we've used in the past, we've not been able to determine it. The radius for the helix inside waveform approach has been set by Edgecam. You've not been able to dictate it, and that's what we see here on the screen is a pretty typical problem. They're not able to reach to the base of the part. If I say go 10 as the smallest and say 90 on the highest, and just let that just do a bit of a number crunch, we'll notice now that yeah, there you go. You can see how the radiuses are not only changed, it's adjusted itself, but it's now managed to get itself all the way into the base of this part where it can. Obviously, maybe some of the tool might be a bit too fat to fit in other areas, but certainly it's done its best to get itself all the way down. So, and also being able to determine the size of the radius is very, very beneficial. We get lots and lots of carbide users, carbide manufacturers whom we work with, asking us to state that value. Go 1.5 times the size of the radius, go 2 times the size of the radius. We've simply not been able to do that. Now, inside the roughing cycle, the helix parameter, you can now determine that by having the maximum and the minimum. I mentioned deep hole drilling. This is, again, very, very popular command that we tend to see. Oil and gas part going all the way, many millimeters, inches into the part, many times the diameter of the tool. Now we're able to support deep hole drilling through the cycle itself, or gun drilling as some people like to call it. And no longer do we have to write a little macro to do changing the spindle direction or changing the coolant condition. We now see that, as we have down our strategies, deep hole. I'm at 667 millimeters per minute, but that's only for one stage of the deep hole process. We'll now notice that we've got deep hole parameters everywhere, and those are now obviously reflected inside the code itself. So if we just do a normal generate code, we'll ask Edgecam to just show us code for that particular part. And the code in this particular case is not going to be too exciting. It's just going to be, tool forward and tool back. But what's more important is it switches the spindle condition depending on where it is, where it is on the stage of the drill. So it's on the approach. It may not turn on the spindle, but it might just simply slow feed into a pilot hole. As it makes its way back out of the hole, what we'll probably see is it will begin to switch off the spindle, or sometimes people like to reverse the spindle. And as they withdraw it at a different feed rate. So here we see the net outcome. As we have different feeds, different spindle conditions and coolant conditions depending upon what's being placed inside the gun drill cycle. Okay, it's very simple, nice, easy one for us to get our heads around. And yeah, so our last one is the spring pass. So again, an industry word, a spring pass is just simply a pass that we take around the component just to remove the elasticity, or give us better size, give us better shape. A lot of people working with plastics, where they know that the part's going to spring a little bit, tend to always do this spring pass idea just to make sure that they get size, get the accuracy. And we see this again, this is inside the profiling cycle. So at the moment, we'll just have a single pass. So round she goes, then comes off again. So that's my final pass. That's taking me down to size, but I might want to do another spring pass on that. So add a spring pass. And the way we would have had to have done that in the past was certainly to drag and drop the profiling cycle. In other words, copy the profiling cycle and do another one and another one sometimes. So if you look at multiple passes, we'll now see that this is where we have spring pass. In this case, it's very simple. Just give me one extra spring pass. And we are, as you can see there, using geometry compensation as well. So that's also supported. And again, it's not going to be very exciting, but it'll just simply walk around the houses once and then not lead off. It will remain on and do me one more pass and only now lead off. So that's our spring pass. Okay, so we're nearly towards the end. Just a quick word about our licensing. So licensing, can't run Edgecam without licensing, so we need to obviously have a quick word about it. Anybody who's got expiry date on your maintenance, October 2017 or later, you'll be able to load up 2018 R1. Those of you with network installations, Sentinel, which is the licensing function, is being updated to RMS 9.1. That's probably, don't really need to say that, but for IT managers, they need to know this because we were at previous versions at 8.3, so you'll now notice that it's moved up to 9.1. We're just keeping in line with technology, and in fact, you probably don't need to know because it's done within the update anyway. The CLS is going to disappear, so that little yellow key that you see in the bottom right hand corner, now that's going to be moved into the license manager. So don't need to fret about it. It's still going to be licensed, but you'll find it inside, like we have a machine manager, or we have a fixture manager, and you don't have a license manager. For those of you, and I doubt very much in the UK, if we have users still using the old legacy HASP and Sentinel keys, the hardware key in the back, do need to swap these over because these are now beginning to die. So we need to go to keyless licensing. So contact your account manager if you have one of those types of legacy licenses. When we install Edgecam for the very first time on a Virgin PC, there's a new license wizard. So when you have installed, you launch Edgecam through your launcher, Edgecam will automatically see that you've no license, and it will automatically go into the license setup. In this case, maybe we'll pick standalone. We'll get our server code. We just paste the server code into our server code area and just say activate, and there we go. So that's done automatically for us, whereas before we would have had to find the command for it. So it's very nicely done through that wizard that we see at the front end of Edgecam. Okay, so big announcement coming up, and this is for a future webinar. We are upgrading, or rather we are introducing a brand new piece of CAD software called Edgecam Designer. So this is we're very excited about this. It's an extremely powerful piece of CAD software, again answering the needs of the modern CAM machinist. Obviously part modeler is still there, part modeler will still always be there, but for users who wish to upgrade, then this is a really good way to move from middle of the road maybe designer to a real purebred piece of design software. So for any of people who want to know and see what all the fuss is about, this is actually being launched in 2018 R1. You do have the functionality on the DVD on the install set. You just need a license. So speak to your account manager. But if you want to know more about this, then please look out for emails that will be inviting you to another webinar, which is going to be on Friday the 15th of December. There'll be a designer webinar to talk about this brand new product, which has been released in 2018 R1 Edgecam Designer. Okay, that's it for me. Thank you very much for your attendance. Sorry I didn't get through all the questions, but you've typed them out. I can see them, so I'll respond to those through email. And yes, for those of you who want to share this recording with colleagues, then by all means, that's no problem at all. It's been recorded and I can send it out to whoever needs it. Okay then, thank you very much for your attendance today. Have a great day and a great week, and we'll see you some more. Don't forget the webinar for Designer on the 15th. Thank you and bye-bye.